Commutator bracket. Commutator bracket is similar to Poisson bracket in classical mechanics. They are related by I h cross t. What is the definition of commutator bracket? Let A and B are two operators. Then commutator is defined as square bracket A B is equal to A B minus B A. So this is the definition of commutator bracket AB. And if AB, commutator AB is equal to 0, that means AB minus operator BA is equal to 0. That is AB is equal to BA. If this is the condition, that is commutator bracket AB is equal to 0, then we can say these operators A and B are commute each other. Now let us discuss the properties of commutator bracket. The first property, commutator A with A, same operator, is equal to 0. And commutator of an operator and a function of this operator also will be equal to 0. And another one is commutator A with a constant is also equal to 0. Second property, commutator bracket A, comma B plus C plus D. Then this is equal to commutator bracket AB plus commutator bracket A C plus commutator bracket A D. Third property, commutator bracket A B is equal to minus commutator bracket B A. Fourth property, commutator bracket A comma B C is equal to commutator bracket. First we have to take combination of these two, that is A B outside the commutator bracket C, plus now we have to make combination with the A and C, that is commutator A C, and one time that B is outside the commutator bracket and its position will be here. Here this position of these operators are very important. Okay, the position of C is here and position of B is here. And if you interchange the position of these operators, then some minus sign will come. Okay. Fifth property, commutator bracket A comma B C. That is, first you have to make combination with the A and C, that is commutator A C, and B is outside, and we can take this B here, plus now we have to make combination of B and C, that is commutator bracket B C, and A is outside, so this position of A will be here. And again I am remembering you, the position of these operators are very important. How one can remember these equations without any confusion? I tell you some ideas. See, in the fourth case, here we are making combination of commutator bracket with the A and B. Okay, so with respect to A and B, the position of C is on its right hand side. So in the same way we written here. First we took commutator bracket of AB, then we placed the C. Okay, and for the next time you have to interchange the positions. And for this case, here the combination is B and C. Okay, for B and C, commutator bracket B and C, the position of A is on left hand side. Okay, right. So for the other case you have to interchange the position. That is, here it is first Here it is last. Sixth property, commutator bracket AB, comma CD is equal to commutator bracket AC DB plus commutator bracket AD CB plus commutator bracket BCAD plus commutator bracket BDAC. Here also the order is very important. I will tell you some trick to remember this order. Okay. So now I am going to discuss the ideas to remember this order. So the commutator bracket is AB, CD, right? Here the first combination of bracket is A and C, right? So this is one, and the remaining is D and B. Okay, so this is the order D, B. Okay, and now it is over. Now we can check the other term, that is, now we have to take combination of A with the D. So AD is in the commutator bracket. The remaining term is CB. Okay, CB. Order is CB. Okay, now another combination AB, CD. Now we are making combination with the B and C, and the remaining term is A and D. Okay, that is BC, and the remaining term is in the order of A, D. Now another combination is with the B and D, that is this one. So the remaining terms are A and C. AC. Okay. For the first term, DB is on the right hand side of this commutator bracket, and for the last term, AC is on the left hand side of commutator bracket. And for other terms, in between terms, it is in the middle. Okay. So I think it will help you to remember the order. Seventh property, that is commutator bracket of A, comma commutator BC plus commutator B, comma CA plus commutator C, comma AB is equal to 0. This is called Jacobian identity. We already discussed this Jacobian identity in Poisson bracket also. Are you remembering? See here, writing this equation, don't be confused. It is in the order, that is A, B, C. Okay, so this is the order of writing the terms. So we will take A as first term, then we take combination of B and C. In the next term we will took B, then inside the commutator bracket we will took C and A in the order, and for the last term, that is, we took C and then we make the combination of A and B. Okay, so there is no confusion, right? And eighth property, commutator bracket A, B, all dagger is equal to commutator bracket B dagger, comma A dagger. So these are the properties of commutator bracket. So when you are learning this commutator bracket, please correlate with the Poisson bracket. Both are almost same. It is differ by only one IH cross. Let us discuss some examples. In classical mechanics, we are much interested in position and momentum of a particle. So the position may be x, y or z. And the momentum corresponds to these coordinates are px, py and pz. In quantum mechanics, this becomes operators. So everyone will get a hat in quantum mechanics. Okay, Now we want to find out the commutator bracket of their combinations. So first I am considering commutator bracket of x cap p x cap. So we know from the definition this is equal to x cap p x cap minus p x cap x cap. Here you know these are operators. So for operator they should operate on something. So I am taking a state psi as a test state. So these operators can operate over this state, that is x cap px cap operating on state psi is equal to x cap px cap minus px cap x cap operating on psi. And here we know the operator px cap is equal to minus ih cross dou by dou x, and x cap operator is x itself. Okay, so we can substitute this operator here, that is commutator bracket x cap p x cap psi is equal to x cap is x itself, px is minus ih cross dou by dou x minus into minus I, that is plus ih cross dou by dou x x cap into psi. Right, so we can expand this function, that is we get minus ih cross x into dou by dou x of psi plus ih cross dou by dou x of x psi. Here there is no cap. Okay, so this is a product of two terms, so this is equal to minus ih cross x dou by dou x of psi plus ih cross, so we have to take derivative of first term, that is dou x by dou x into psi plus ih cross x into derivative of second function, that is dou psi by dou x. See, these two terms are same and they are opposite in their sign, so this will cancels, and here we know dou by dou x of x is nothing but 1. So we will get x cap px cap psi is equal to ih cross into psi. That means commutator x cap px cap is equal to ih cross. Okay, so we got the value of commutator x cap px cap, that is equal to ih cross. So the first combination, that is x cap px cap, we obtained as ih cross. Similarly, if you solve for y cap p y cap, you will get ih cross, and similarly if you solve for z cap p z cap, again you will obtain ih cross. And if you solve for other combination, that is commutator bracket of x cap with the p y cap, you will get this is equal to 0, and if you solve for x cap p z cap, again you will get this is equal to 0, and the other combination, that is y cap p x cap, you will obtain equal to 0, and the combination of y cap with the p z cap also you will get equal to 0, and the sixth combination z cap, commutator bracket of z cap p x cap equal to 0, and z cap p y cap is also equal to 0. You please solve these equations and verify by yourself. Okay. Earlier when we are discussing the properties, I told you one thing. If the commutator bracket of two operator is equal to 0, then we can say they are commute each other. What is it meaning? That is x cap py cap is equal to py cap x cap. Here these are operators, right? Suppose x cap p, x cap is an operator and is operating on some state psi, then the order of operation is first this px will operate on this psi, then this x cap will operate on the resultant, and the p x cap psi means first this position operator will operate on this state, so we will get another vector, and on that vector this p x cap operator will act. So if they commute each other means the order of operation is not important. That is, whatever the order, you will get the same answer. So for all these combinations, order is not a matter. But for this combination, the order is very important. That is x cap, p x cap minus p x cap is IH cross. That means if px is first operates on the state, then x is operating on that state. So we will get a value. And that value is not equal when first position operator operate on that state, then momentum operator operate on that state. There will be a difference of IH cross. Okay. So x and px will not commute. Example problem type 1. So in this section, we will discuss combinations of x cap and px cap. Okay, first question. Commutator bracket of x square px. Here we know we can expand this as x cap, comma, px cap. So we can expand as x cap, px cap. So first we are making the combination of commutator bracket with these two terms. Okay, and remaining term is on left hand side. Plus, now we can make the combination of x and px cap. That is x cap, px cap. The remaining x will be here. So we know the value of x cap, px cap, that is IH cross. This one also IH cross. So we will get this is equal to 2IH cross x cap. See, this result is also equal to commutator bracket of x cap, px cap into x cap square derivative. Okay, so here we took the order of commutator bracket as given in the question, that is first x then px, and x square is a function of x cap, so we took its derivative. So what we will get? We will get the same result. Okay, another example. Poisson bracket of x cap p x cap square. Here also we can do in this method, or we can use this method. What is this method? That is, we have to write the Poisson bracket x px. See, the order is same here also. Okay, and px cap square is a function of px, so we have to take its derivative. So this is equal to commutator bracket of x cap, px cap is IH cross, that is IH cross into derivative of px cap square, that is 2px cap, that is equal to 2IH cross px cap. If you solve in this way, then also you will get the same result. So this is a tricky method to solve such problems. Third example problem, Poisson bracket of x cap raised to n px cap. So here also we can use the above trick, that is, we have to write the Poisson bracket of x and px, that is x cap, px cap in the same order into, here x raised to n is a function of x cap, so we have to take its derivative. So this is equal to IH cross into n x raised to n minus 1. So we can make a general formula. and we can use this general formula to solve any kind of problems. That is commutator bracket of function of an operator with another operator b. Then we have to take commutator bracket of a comma b. Then we have to take derivative of this function. Or if it is like this one, that is a cap into function of b cap, then this is equal to commutator bracket a cap b cap. See, I took the same order. First here a, then b. Okay, into derivative of b operator. So by using this formula, you can solve many problems very easily. Fourth example, commutator bracket e raised to x cap comma p x cap. This is equal to, here we can use the above general formula, that is commutator x cap p x cap into, here this is a function of x, so derivative of e raised to x cap. So that is equal to I h cross into derivative of e raised to x cap is e raised to x cap itself. Another example, commutator bracket of e raised to x cap square p x cap. That is equal to, again, x cap p x cap into e raised to x cap square derivative. That is equal to I h cross into derivative of this function is e raised to x cap square into 2x cap. Sixth example, commutator bracket of x cap log px cap. So that is, yeah, commutator bracket of x cap px cap into log px cap derivative. That is equal to I h cross into 1 by p x cap. Seventh example, commutator p x cap log x cap. That is equal to, here we have to take the same order of commutator bracket, that is p x cap x cap. See, px is first, x cap is next. Now we have to take the derivative of the function, that is log of x cap. That is, here what is the value of commutator bracket px cap x cap? It is minus I h cross into derivative of this function is 1 by x cap. Eighth example, commutator bracket of sin x cap p x cap. That is equal to commutator bracket x cap p x cap into derivative of sin x cap. That is equal to I h cross cos x cap. So try for this problem, that is cos x cap p x cap, and the 10th one, commutator bracket x cap square p x cap square. Solve this by yourself, okay? And I tell you this one because it is little importance is there. So how we can solve this problem? First we can expand this function, that is x cap into px cap square. Okay, so this is equal to, first we can take the combination of x cap and px square, that is x cap into commutator bracket x cap p x cap square, plus now we can make the combination of these two, that is x px cap square into x cap. So now we can easily solve, that is x cap into solution of this commutator bracket is commutator bracket x cap p x cap into derivative of p x cap square, plus this is x cap p x cap into derivative of p x cap square into x cap. That is, this is equal to x cap into I h cross into 2 p x cap plus I h cross into 2 px cap into x cap. Now we can rearrange and simplify this equation. That is 2i h cross into x cap px cap plus px cap x cap. Can we write this is equal to 2i h cross into 2x cap px cap? No. Why? I told you in the earlier case, commutator bracket of x cap px cap is equal to i/h cross. That is, x cap px cap is not equal to px cap x cap. So we can add this term, and so we can write it as this one. Okay, so this is wrong because x cap px cap and px cap x cap are different, because these operators are not commute with each other. So this is the answer. Okay, but if you are using the Poisson bracket, you can add. Why? Because in Poisson bracket, the order of x and px are not important. But in the quantum mechanical commutator bracket, the order of the operator is very, very, very important. Another example problem. A Hamiltonian is given, and if a Hamiltonian is equal to px cap square by 2m plus half k x cap square, then find, first question, commutator bracket of x cap h cap. So that is equal to, you have to substitute this value here, that is x cap comma px cap square by 2m plus half k x cap square. So we can expand this, that is commutator x cap px cap square by 2m plus x cap comma 1 by 2 k x cap square. Here we can take the constant term outside, that is 1 by 2m into x cap p x cap square plus 1 by 2k commutator bracket x cap comma x cap square. Here this is equal to 1 by 2m into, you know how we can solve? You have to take commutator bracket of x cap px cap into derivative of px cap square plus, see here, commutator bracket of an operator with itself is definitely equal to 0. So this is equal to 0. So we will get this is equal to 1 by 2m into i/h cross into 2 px cap. That is, the result is equal to, we can cancel this 2 and 2. So i/h cross px by m. Question B. Find commutator bracket of x cap, commutator x cap, h cap. Here we already evaluated this term, and this value is equal to i/h cross px by m. Okay, so this is equal to x cap comma i/h cross px by m. That is equal to, we can take the constants outside, that is i/h cross by m into x cap px cap. So what is the value of this one? That is equal to i/h cross, that is we get i/h cross by m into i/h cross. So this is equal to minus h cross square by m. Now question C. Find commutator bracket of x cap, commutator x h cap. See, we already evaluated this much, right? That is equal to x cap comma this term is equal to minus h cut square by m, and this value is a constant value, right? And I already told you in the properties, commutator bracket of an operator with a constant is equal to 0. Now a question for you. Question is D. Find Px cap h cap, then find Px cap h, then find Px cap Px cap h. This is a work for you. Okay, please do these problems. Angular momentum. In classical mechanics, we represent this angular momentum by L vector, right? And what is this angular momentum? If a particle of mass m is rotating about an axis like this. So this is axis and it is rotating about this axis. So this will be the r vector and it will have certain velocity this direction. So if we know the r vector and velocity, then L vector, that is angular momentum, is defined as r vector cross p. And here we know r vector is equal to xi cap plus yj cap plus zk cap. And we know p vector is equal to px I cap plus py j cap plus pz k cap. So r and p are vectors, so we can find out L is equal to r cross p. So how we can solve this r cross p? That is I j k x y z p x p y p z. So this is equal to I into y p z minus z py minus j into x pz minus z px plus k into x py minus y px. Right? This is L vector. And we know L vector can be represented as I cap Lx plus j cap Ly plus k cap Lz. So we can compare the coefficient of I cap, j cap and k cap. Right? So they will be equal. So we will get Lx equal to y pz minus zpy and Ly is equal to z px minus x pz and Lz is equal to x py minus y px. So these are the components of angular momentum in classical mechanics. And when they are in quantum mechanics, they will get a hat. So they will become an operator. So everything is operator in quantum mechanics. Okay, so this is the corresponding quantum mechanical angular momentum operators. Example problems type 2. Here in type 2, we discuss commutator bracket of angular momentum operators. First example problem, commutator bracket of Lx, Ly. So how we can solve? We have to substitute the value of Lx and Ly in this commutator bracket. That is Lx equal to y cap p z cap minus z cap p y cap, comma Ly, that is z p x cap minus x p z cap. So now we can expand this commutator bracket That is, first I am taking the combination of these two, then I will take combination of these two, then I will take combination of these two, and last I will take combination of these two. Okay, therefore this is equal to commutator bracket y cap p z cap comma z p x cap plus, here there is a minus sign, so it become minus y cap p z cap minus, that minus we already took outside, so x cap p z cap minus z cap p y cap comma z cap p x cap. Minus and minus, there is 2 minus, so it becomes plus commutator bracket of z cap p y cap comma x cap p z cap. In the classical mechanics class, I told you some trick to remember these equations. What is that trick? That is, first x, then y will come, then z will come. Okay, this is the order, cyclic order. So see, x is here. So what is the next term? Y. So y is come here. Then what is the next term? Z. Z become pz. And the next term minus reversal of these two terms. So you have to interchange y and the z. Okay. So it is applicable to everything. See, this is y. The next term is z. So we start with z. Then the other term is x. So that is px minus. Now we are interchanging this z and x. Okay, so this is the trick to remember these equations. Now we have to solve all these commutator brackets. When we are discussing the property, I told you a very big equation for this one itself, right? So writing all those equations and solving is not an easy job. So how we can solve in a easy way? This also we discussed in classical mechanics when we are discussing the Poisson bracket. So the method of solution is, we have to look for a coordinate and its corresponding conjugate momentum. That is, for this case, z is there and pz is also there. So this term will not be equal to 0. Now for y there is no py term and there is x coordinate is there, but there is no px term. So definitely this become equal to 0. And here also z is there and there is no pz. So this term also will be equal to 0. And here z is there and its conjugate momentum is also there. So this term is also not equal to 0. So we have to take the Poisson bracket of these two terms only, that is equal to y cap p z cap comma z px cap. So this term are 0 0 minus 0 minus 0 plus. Now we have to take the commutator bracket of this term, that is, this is the second combination, right? That is z cap pz. And I told you, if this is the case, then x py, that is the order, that is x cap p y cap. So this is equal to y cap. We now commutator bracket of p z cap is minus I h cross into p x cap plus x cap into commutator bracket of z cap p z cap is I h cross into py. That is, this is equal to I h cross into x py minus y px. All are operator. And we now see this term is nothing but Lz x cap py cap minus y cap px cap. So commutator bracket L x cap L y cap is equal to I h cross Lz cap. Now I give you a work for you. Find commutator bracket of Ly, Lz. And find commutator bracket of Lz, Lx. Please solve by yourself. So we got commutator bracket of Lx cap, Ly cap is equal to I h cross Lz. Similarly, if you solve for this one and this one, you will get the solutions as Ly cap, Lz cap is equal to I h cross Lx. And if you solve for the other case, that is Lz cap, Lx cap, then you will get a result I h cross Ly. So in general, this is Li cap, Lj cap, then this is equal to I h cross Ijk Lk. What is this meaning of this term? This is positive one for order and negative one for disorder, and it is equal to 0 if the terms are repeating. That is, what is this order? Order is Lx, Ly, Lz. This is the order. If they are in the order, then it will be positive. That is, this is Lx, Ly. So this is in order. So this is positive Lz, right? And if it is Ly, Lx, then now it is in disorder. So we will get minus IH cross Lz. Okay, that is the meaning of this term. And if they are repeating, that means Ly cap, then that is equal to 0. Now let us discuss some more example problems. So first I am taking x cap and I am making combination with the Lx cap, Ly cap and Lz cap. Okay, so first one is x cap with the Lx cap. That is equal to commutator x cap. We know the Lx cap is y cap p z cap minus z cap p y cap. So we can expand this one, that is commutator x cap y cap p z cap minus x cap z cap p y cap. See, if you are taking x cap, then check whether there is its conjugate momentum is present. That is, px is present. No. Right. So this term will give 0. And here also x is there, and check whether its conjugate momentum is present. That is, px is present. So here also px is not present. So definitely this value also will be equal to 0. If you have doubt, you please expand this commutator bracket and you can find this will be equal to 0. Another combination, that is commutator x cap with Ly cap. That will be equal to x cap. Ly is z cap p x cap minus x cap p z cap. That is equal to, we can expand as x cap z cap p x cap minus x cap p z cap. Here, when we are considering this x cap, there is a conjugate momentum, that is px is present. Okay, so this value is not equal to 0. And here, when x cap is considering, there is no px term. So this is definitely equal to 0. So we have to expand only this term, that is commutator x cap z cap p x cap plus z cap commutator x cap p x cap. Here we know this term is also equal to 0. So 0 plus z cap into x p x cap, that is I h cross. That is the value of commutator x cap L y cap is equal to I h cross z cap. Third one, commutator bracket of x cap with the L z cap. That is equal to x cap. L z cap is x p y cap minus y p x cap. So we can expand as x cap p y cap minus x cap y cap p x cap. Here also, if you are taking this term x cap, then there is no momentum conjugate, so this term will be equal to 0. Here we are considering this x cap, so there is its momentum conjugate is present, so this term is not equal to 0. That is 0 minus, again we can expand this function, that is x cap y cap into px cap minus y cap into x cap px cap. So this is equal to 0 minus this term is also equal to 0 minus this term, that is y cap into xpx, that is I h cross. So we got x cap L z cap is equal to minus I h cross y cap. So we got commutator bracket of x cap L x cap is equal to 0 and the commutator bracket of x cap L y cap is equal to I h cross z cap, and we got commutator bracket of x cap L z cap is equal to minus I h cross y cap. And if you solve for other combination, that is y cap L x cap, then you will get minus I h cross z cap, and if you solve for y cap L y cap, then you will get this is equal to 0, and if you solve for y cap L z cap, you will get I h cross x cap. And other combination, that is z cap L x cap, you will obtain as minus I h cross y cap, and z cap L y cap you will obtain as, sorry, this one is plus, and this one you will obtain as minus I h cross x cap, and ninth one, that is z cap L z cap, you will obtain as equal to 0. So from these equations we can make some general ideas, that is the angular momentum operator rotates other coordinate cyclically. What is this meaning? Let us consider one example, this one, that is x cap L y cap is equal to I h cross z cap. So this is our angular momentum operator, right? Here we know x cap is there, y cap is there, and z cap is there. So x cap L y cap. So L y cap rotate x cap in a cyclic way, that is it become z cap. That is why we got z cap here. So here the order is x, y, y, z, right? Now we can check another case also, this one, that is commutator bracket z cap L y cap is equal to minus I h cross x cap. See here first one is z cap y. So the order is reversed, that is why there is a minus sign. So then the other term is x cap, right? Z is there, y is there, the other term is x cap. Okay, so this is the method to remember these equations. Now we can consider the combination of px with Lx, Ly and the Lz. That is, first combination is Px cap Lx cap. That is equal to, we can expand this, that is Px cap, we know Lx cap is y Pz cap minus z cap Pz. So we can expand this, that is commutator bracket Px cap y Pz cap minus Px cap z cap Pz cap. See here, y is there and check whether there is py is there. No, right? So this will be equal to 0. And here z is there and check whether its conjugate momentum is present or not. Yeah, yes, present. But it is in the same side. So this will also equal to 0. So this value equal to 0. Now we can check second one. That is Px cap with the Ly cap. That is equal to Px cap. Ly is z cap Px cap minus x cap Pz cap. So we can expand this, that is Px cap comma z cap Px cap minus Px cap comma x cap Pz cap. Again check, z cap is there but there is no Pz, so this term will be equal to 0. And here x cap is there and Px cap is also there. So this is not equal to 0, that is this is equal to 0 minus, we have to expand this term, that is commutator Px cap comma x cap minus, because minus is from outside, so into next combination is Px with the Pz, that is Px cap Pz cap. The remaining term is, sorry, here I missed the Pz cap and here the remaining term is x cap here. So definitely this term is equal to 0 and here this one will be equal to minus into minus I h cross, because position of x and px are reversed. Okay, so into Pz cap. That is, this is equal to, that is Px Ly cap is equal to I h cross Pz. In a similar fashion, you please solve for the other term, that is Px cap Lz cap. Okay, this is a work for you. Now we can summarize all those values, that is combination of, first combination is combination of Px with the Lx. So we got this is equal to 0. Second combination is combination of Px with the Ly and we got this is equal to I h cross Pz, and the third combination is Px cap with the Lz cap, and we got this is equal to minus I h cross Py. And if you solve for other problems I already assigned to you, then you will get fourth one, that is Py Lx is equal to minus I h cross Pz, and the fifth one Py cap Ly cap is equal to 0, and the sixth one Py cap Lz cap is equal to I h cross Px, and the other combination, that is commutator Pz cap with Lx cap, you will get this is equal to I h cross Py, and the Poisson bracket of Pz cap with the Ly cap we will obtain as minus I h cross Px, and the ninth one you will get Pz cap Lz cap is equal to 0. Here also we can use the earlier trick, that is the function of angular momentum operator is rotate the other coordinate in a cyclic manner. That is, let us check this case, that is commutator Px cap L y cap. That is equal to, so here x is there, y is there. So the cyclic order, that is x, y, z. This is the cyclic order. So in cyclic order, the next term will be of z, right? That is why we got IH cross PZ. Okay, so this angular momentum operator Ly cap rotated the other coordinate, that is Px cap, in a cyclic way. So x, y, and now it is z. Now we can check this one. So that is commutator Py cap L x cap is equal to minus IH cross PZ cap. See, first term is y, then it is x. So the order is reversed, right? So if order is reversed, then there will be minus sign. This minus sign is due to disorder. Okay, so y is there, x is there. So the remaining term is z. Okay, so this is the answer. Please remember this trick, then you can solve many problems. Okay. An important note. The commutator bracket of R vector, L vector is equal to 0, and the commutator bracket of P vector with the L vector is also equal to 0. So this thing we already discussed in Poisson bracket case also, right? And if you have any doubt, you do one thing. You know what is R vector? It is x cap plus y cap plus z cap. And what is L vector? That is Lx cap plus Ly cap plus Lz cap. And here we know P vector is Px cap plus Py cap plus Pz cap. So you substitute these values and solve. Okay, so finally you will get these answers. So this one is also a work for you. Please solve by yourself and verify whether these equations are correct or wrong. Okay. Example problem type 3. Here the question will be like this one, that is commutator bracket of x cap dou by dou x. Then how we will solve? We know one thing, that is Px equal to minus IH cross dou by dou x. So dou by dou x can be written as minus Px by IH cross. So we can substitute this value in this equation, that is x cap dou by dou x is minus Px by IH cross. So that is equal to, we can take this constant term outside, that is minus 1 by IH cross into x cap Px. That is equal to minus 1 by IH cross into, we know the value of x cap Px, that is IH cross. So we will get x cap dou by dou x is equal to minus 1. Second question, that is commutator bracket of x cap square dou by dou x. What is its value? Here we can use the earlier trick. What is that trick? See, this one is equal to x cap dou by dou x cap. Okay, into derivative of this function, that is x cap square derivative. So that is equal to, we know value of x cap dou by dou x, that is minus 1 into x square derivative is 2x cap, that is equal to minus 2x cap. Now third question, commutator bracket of x cap dou square by dou x square. Here also we can use the above trick, that is it is a function of x cap and dou by dou x. So first you have to take the commutator bracket of these terms in its same order. So here first x cap, then dou by dou x. So here also we wrote x cap first, dou by dou x second. Okay, now we can take the derivative of this function, that is dou by dou x square derivative. So this is equal to, we know the value of this term, that is minus 1 into derivative of this one is 2 into dou by dou x. So we get minus 2 dou by dou x. So in general we can say, if it is look like f of x dou by dou x, the commutator bracket look like this one, then this is equal to, we have to take x cap dou by dou x first, then we have to take derivative of this function. So we will get minus of f dash of x. And now let us discuss some more examples. So the first example problem is x d by dx x square. Find commutator bracket of this one. So first what you have to do, you have to separate this, that is x into d by dx comma x square plus x comma x square into d by dx, where we know this term will give 0 and we have to evaluate this term. Okay, that is equal to x into, here the order is d by dx comma x into derivative of this function, that is 2x, and we know the commutator of x cap d by dx is equal to minus 1. So now it is reversed, so this will be equal to plus 1. Okay, so we will get this is equal to 2x square. Another example, x cube d by dx comma x. So this is equal to, again we have to expand this one, that is x cube into d by dx comma x plus x cube comma x d by dx. Here also this term definitely will be equal to 0 and we have to evaluate this term. And this term we know this is equal to plus 1, right? So the solution is equal to x cube. Third one, x comma p e raised to minus x. So we have to expand first, that is x comma p e raised to minus x plus x comma e raised to minus x into p. Okay, so this is a function of x and x, so this will be equal to 0. And here we know commutator bracket of xp is equal to I h cross e raised to minus x. Fourth question, commutator bracket of p comma x e raised to minus p. So again we have to expand, that is p comma x e raised to minus p plus p e raised to minus p into x. So this is a function of x only, so this is equal to 0, and here we know it is px, that is order is changed, so there will be a minus sign, that is minus I h cross e raised to minus p. Fifth one, commutator bracket x comma p e raised to minus p. So we can expand, that is x comma p into e raised to minus p plus x comma e raised to minus p into p, right? So this is equal to, we know xp is equal to I h cross e raised to minus p plus p into, here this is a function of e raised to minus p, so first you have to take p into derivative of this function, that is e raised to minus p derivative. So this is equal to I h cross e raised to minus p plus p into commutator bracket of xp is I h cross into derivative of this function is e raised to minus p into minus 1, right? That is, we will get this is equal to I h cross e raised to minus p into 1 minus p. Sixth example, commutator bracket px, comma x cap e raised to minus x. So here also we have to expand this one, that is px x cap e raised to minus x plus commutator bracket of px e raised to minus x, and the remaining term is x cap. So this is equal to, here this term will be minus I h cross e raised to minus x plus x cap. Here this is a function of x, so we have to take px x cap into derivative of this function. Okay, so this will be equal to minus I h cross e raised to minus x plus x cap. Px x cap is minus I h cross into derivative of this function is e raised to minus x into minus 1. So we will get this is equal to minus I h cross e raised to minus x into 1 minus x cap. Seventh problem, if a is equal to d by dx and b is equal to x cap and a, b minus c is equal to I, then find the value of c. Here all are operators, right? So b operator, a operator and all. Okay. So how we can find out? First we have to solve this one. A operator, b operator. That is, what is a operator? D by dx into what is b operator? X cap. Now these are operators and this operator how to operate on something. So I am taking a test vector, that is psi. Now we can operate this operator on this side. Okay, so what we will get? First this x cap operator will operate on x, right? So what we will get? D by dx into x psi. Okay, and now this d by dx operator will operate on this term, that is equal to, it is a derivative of product, that is, first we can take x into d by dx of psi plus psi into d by dx of x. So that is equal to x into d psi by dx plus psi, because dx by dx equal to 1. That is, we got a b is equal to, that is ab psi is equal to this one. Here we can cancel this side term, that is test wave function from both sides, that is we get a b is equal to x d by dx plus 1. And the question, it is specified a operator, b operator minus c operator equal to I. I is identity, that is equal to 1. So that is what we got. We got a operator, b operator is equal to x d by dx plus 1 minus c operator equal to 1. So we can cancel these two terms and we get c operator is equal to x d by dx. Eighth example problem, that is, if L plus or minus is equal to Lx plus or minus I Ly and R plus or minus is equal to x plus or minus Iy, then you have to solve for L plus R plus, second one L plus R minus, third one L minus R plus, and fourth one commutator bracket of L minus comma R minus. So this is a work for you. I will help you to solve the first one, then you have to do second and third and fourth one. Okay. That is, what is first one? That is L plus R plus. What is L plus? That is Lx plus I Ly, comma. What is R plus? That is x plus I y. So we can expand this as Lx, comma, x plus Iy plus Ily, comma, x plus Iy. This is equal to, see, we can expand this again, that is Lx, comma, x plus Lx, comma, Iy plus Ily, comma, x plus Ily, comma, Iy. So what is this value? We already know this is equal to 0 plus what is Lx Iy, that is I into, I is the constant term, into here Lxy. See, the order is x, y. So I already told you the Lx operator, that is angular momentum operator, will give the other term. So here the other term is z. So I h cross z plus this term. Here I is a constant term, so we took it outside, and the remaining is Lyx. Lyx. So first is y, then is x. So all this different. So it will be minus I h cross, and the other term is z cap. Plus here also I can take outside into I. So into Lyy. We know Lyy is equal to 0. Okay. So this is equal to I into I, that is minus h cut z cap. Here I into minus I, that is plus h cross z cap. So this is equal to 0. Similarly, you have to solve for second one, third one, and the fourth one. This is a work for you. Okay. Please solve it. Then only you will be good in solving such kind of problems.